decipher something from figure 1 and figure 2 here. Figure 1, right? How do we relate 5 amps with any one of the two meshes? So in figure 1 there are two meshes. How do we relate 5 amps with the mesh currents? If you say that I2 is equal to minus 5, it is perfectly right? So in figure 1 we can associate 5 amps with any one particular mesh current, right? Now what about figure 2? In figure 2 we can say, or one can observe, that I1 is equal to minus 6, or one can say that I2 is equal to 6 amperes, right? In the sense, what I want to convey here is 6 amps is between two meshes, right? Whereas 5 amp is associated with only one mesh, that is mesh 2. Let us not debate about its orientation here. So 6 amps is either associated with I1 or I2 or both, right? So under such dilemma, whenever we have a current source associated with two meshes, we have to apply a concept of super mesh, right? So actually I1 and I2 are mesh currents and 6 amp is actually a branch current. So we have to write the equation such a way that branch current is equal to two mesh currents, right? So how do we write, or how do we associate 6 amps with I1 and I2? So you can see I1 travels right through 6 ohms, comes down to 2 ohms, and then you can see the direction of I1 is opposite to 6 amperes. What about I2? I2 travels through 10 ohm, goes down to 4, moves left, and it travels in the same direction in the branch 2 ohm and 6 amperes. Thus, as I2 is in same direction of 6 amperes, we say I2 positive, and as I1 is opposite to 6 amperes, we say I1 as negative. So this is how we have incorporated branch current and mesh currents. So 6 amps is actually your branch current, right? And I1, I2 and I1 are your mesh currents. So we have now linked branch current and mesh current, right? So this is how you have to write the equation, right? So now let us proceed further and understand mesh analysis with respect to supermesh. Now, when a current source exists between two meshes, right, as shown earlier, we have a current source 6 amperes between two meshes I1 and I2, right? We create a supermesh by excluding the current source and the element in series with it, right? A supermesh is created after we exclude the current source and any element in series with it, right? So then supermesh results when two meshes have a dependent or independent current source in common, right? As you can see, we have 6 amperes, which is an independent current source, which is common for I1 and I2. Thus we have to solve this sum by supermesh, right? So 6 amperes, let us write the equation for 6 amperes with respect to I1 and I2. We have seen that earlier. I'll call that as constraint equations, right? So constraint equation, that is nothing but I2 is in the same direction of 6 amperes and I1 is opposite to 6 amperes. Thus we write the equation as 6 is equal to I2 minus I1, and I write that as equation 1, right? Now we are under mesh current analysis. Now there are two meshes, thus we'll have two equations to solve for. Now we have one mesh, we have one equation. Now we have to write one more equation, that would be from supermesh. And how do we write? Exclude the current source and the element in series with it, right? So let us see. So exclude not only the current source, the entire branch, that is 2 ohms also. Then apply mesh analysis, right? Holistically for mesh 1 and mesh 2, simultaneously write down the equation. Earlier what we used to do, we used to write mesh 1 separate, mesh 2 separate, and thereafter we used to solve. But for supermesh, since both mesh 1 and mesh 2, they appear in supermesh, right? So what we have to do, we have to holistically write mesh equation for mesh 1 and mesh 2 simultaneously. That is 6I1 plus 10I2 plus 4I2 minus 20 is equal to 0, right? As we rearrange the equations, so as you substitute in calculator, you get the answer as I1 as minus 3.2 amperes and I2 as 2.8 amperes, right? So this is how we have to apply supermesh. Now let's take one more problem to understand. So here they've asked us to apply mesh current analysis, determine mesh currents, current through 10 ohm, Vx and Va. Now mesh currents. So what we have to do first is remove the unknown questions first. Remove Vx and Va, right? So now by mesh current analysis, right, how many unknowns are there? So do not see a question. There are 4 unknowns in a given question, right? By mesh analysis we have 3 unknowns. Which are those? I1, I2 and I3. Thus we need 3 equations with respect to I1, I2 and I3. In all the 3 equations we should have I1, I2 and I3. If any variable are not there, we can associate that to 0. Now let us write the constant equation for 4 amperes. As you are aware, this is supermesh. Why? Because 4 amperes is associated with 2 meshes I1 and I2. So, right? So I give you the equation as I1 minus I2 equal to 4, or 4 is equal to I1 minus I2. Why? As you can see, I1 current travels in the same direction of 4 amperes, thus I1 is positive. I2 current is traveling right, down, left, it's going top, and as you can see it's traveling in opposite direction, thus I2 is negative, right? And what is that equal to? That is equal to 4 amperes. Now what you have to do? We have got one equation, we have to get 2 more equations. As soon as you write the constant equation, apply supermesh. How do we apply supermesh? Remove the current source along with the entire element in series to it. Remove the 3 ohm also. Then apply mesh analysis to its periphery. Apply mesh analysis for mesh 1 and mesh 2. And our equation is 5I1 minus 5I3. As you can see, 5, this 5 ohm, you have both I1 and I3. Similarly 10 ohm, you have both I1 and I2. And this 20 ohm, we have only I2. And then followed by 24 volt. And then this is your equation for supermesh. Simplify that equation, that is your equation 2. Then where should we apply? As we know, we have 3 equations. Now we have got 2. Where do we apply mesh analysis to get your 3rd equation? So we apply at mesh 3. So equation for mesh 3, I hope this is simple. This is your equation for mesh 3. Rewrite it. Now once you substitute in calculator, these are your answers for I1, I2 and I3. That is 4.8, 0.8 and 1.6 amperes. So your first question, what are your mesh currents? Your mesh currents are I1 is 4.8, I2 is 0.8 and I3 is 1.6. Now let's find current through 10 ohm, right? So now which all currents are flowing through this 10 ohm? Which all currents are flowing through this 10 ohm, right? The answer is I2 and I3, right? So then the equation for 10 ohm would be, what's the current through 10 ohm? Now you can see they have not given the polarity, the direction of current. Preferably write the positive answer. So then out of I3 and I2, which is greater? I3. We write the equation as I3 minus I2, which is 0.8 amperes, right? So I3 is traveling towards left and I2 is traveling towards right. These two are the currents flowing. As they are in opposite direction, we subtract them. Which is greater? I3. So your resultant current will be traveling left. And the answer is 0.8 amperes. Now let's find for Vx. Where is Vx? Vx is across 5 ohm. And your answer for Vx is hidden in this equation. I'll leave you to inspect for the answer for Vx. But let me tell you the answer. What current or which all currents are flowing through 5 ohms? There is nothing but which all currents are flowing through 5 ohms? I1 is flowing from top to down and I3 is flowing from down to top. And we write the equation as I1 minus I3 into 5. Why I1 is positive? Why I3 is negative? I1, as you can see, the current which is circulating, it hits positive polarity first, that's why I1 is positive. I3, it hits negative polarity first, that's why I3 is negative. So I into R, that is your branch current, into resistance will give you the voltage Vx, which is 16 volt. Next, how do we solve for Va? Right? So Va, where is Va? It is voltage across current source. So what is the first step? First step is assume that you have removed Va. Assume that you have removed the current source. Now, as there are 2 cases here, let us see case 1 and case 2. In exam, we can take up any one case, but let us holistically understand both. Right? So case 1. So when you see through this side, when you see through this window, between red and black, what all elements do you see? So I repeat, when you see through this window, what all elements do you observe across red and black knobs? You observe 5, 24 and 3 ohms. Right? So between those two, when you observe left, you see these 3 elements, 5, 24 and 3 ohms. So voltage up across that is nothing but VA. Right? That is 5 into I1 minus I3 plus VA plus 3 into I1 minus I2 minus 24 is equal to 0. Right? When you apply mesh analysis over here with respect to the currents, when you substitute, you get the answer as minus 4 volt. Case 2. Right? What is case 2? Now, why did you observe towards left? Why not towards right also? Right? It's a window where you can observe or peep in towards left and right. So as you see towards right, so let us see. As you see towards right side of this window, what all do you observe? Or which are elements? You observe 10, 20 and 3 ohm. So voltage drop and VA. Right? So voltage drop across these 3 elements will give you minus 4. In an exam, you can do either as case 1 or case 2. Anyone. Do not do both because they are parallel across those 2 ends. Across your red and black knob, they are parallel and the voltage remains same in parallel. So in exam, do it for any one mesh. So 10 into I2 minus I1 plus 20 into I2 plus 3 into I2 minus I1 minus VA equal to 0. So when you substitute, you still get same answer as minus 4 volts. Right? That's about Supermesh. Thank you.